Hi guys, welcome to this video. This is Dr.M.MOORTHI, working as Assistant Professor in the Department of Automobile Engineering, SNS College of Technology, Coimbatore. So in this video, we are going to see about a topic called gear ratio. So this gear ratio is how this gear ratio will affect the transmission of that is power from the engine component to engine to the wheels, and then with different gears shifting mechanisms that are used in the gearbox. So generally, in the transmission system, the gearbox will play a major role to transmit the power from the engine to the wheels with help of the transmission system. So this transmission system includes the major components called clutch, gearbox, and then drive shaft, and then differential unit, then rear wheels. So these are the major components that are employed during the transmission of power from the engine to the wheels. So where the engine power is once the power is generated, that is delivered from the engine, and then this is first it is transmitted to the clutch with a flywheel, and then all the output shaft of the clutch is attached to the gearbox, that is the input of the gearbox, and then output shaft of the gearbox is connected to the drive shaft, so that we can easily transmit the power during the transmission. So this is what we are having the transmission system in order to run the vehicle with a smooth manner. So in the gearbox, already we have discussed what is the gears, and then different types of gears, and then what are the different functions of gears that enables the vehicle to shifting the gears. And then with that we have another part that is very important, that is the gear ratio. This gear ratio is the ratio between the number of driven gear teeth to the number of teeth on the drive gear. So this is the gear ratio, where we have in the gearbox we have gears called drive gears and then driven gears. So this drive gears is this attached to the power medium, so that it gets the power from the clutch, so that it runs the gear, and then so that we can change or to shift the gears from one to the maximum number of gears that we have in the particular vehicle. So where this drive gear will receive the power, with that power it is run, and then the driven shaft doesn't get the power from the unit, but it is running based on running where these teeth is connected to the drive shaft. So first we have the clear thought in that what is a drive gear and driven gear, and I'm just repeating again. This drive gear will receive the power, and then with that power it run, and then whereas the driven gear, it doesn't receive any power, but it is running because these gears on the that is the teeth on the driven gear is that is it is less with the drive gear teeth, so that it can run accordingly where the drive gear is running. So see here in the diagram, the driven gear has 24 teeth, and then whereas the driving gear it have 12 teeth. So this drive gear is running fast compared to driven gear, whereas it has the number of teeth is higher than the drive gear. So this yellow color, that is it is different with a different color. This yellow color is a drive gear, it receives the power, and then whereas the driven gear it run with help of the drive gear. And see here, the driving gear makes one revolution, and then driven gear makes half revolution. Yes, because it is have the two times as the gears, that is the teeth in the drive gear. So next, yes, I'm just already we have discussed. A gear ratio is the ratio between rotational speed of two missing gears, that is generally drive gear and driven gear. When these ratio follow a geometrical series, each gear is designed so that the ratio between consecutive gears is constant. The gear ratio is n output divided by n input. That is n, that is the driven gear, the number of teeth on the driven gear divided by number of teeth on the drive gear. So what is geometrical series? So each of term after the first is found by multiplying the previous term by a fixed and then a non-zero number called is common ratio. So this gear ratio and then this gearbox will have the applications like the true smooth transition of the power from the engine to the wheels, and then efficiency. So with the effective gear ratio will have the greater efficiency in the vehicle, so that we can increase the fuel efficiency, and then and also we can with that we can reduce the fuel consumption during the power transmission. Thank you.